Hello students, how are you today? Welcome back with a new lesson of physics, grade 9. Now we will study gas law. When we want to study gas law, we must know 4 variables of the gas: its pressure, temperature, volume, and moles. But in this lesson, we just work with volume, pressure, and temperature. And we will see the relation between pressure and volume, pressure and temperature, temperature and volume. Characteristics of gas. At first, gases expand to fill any container. Random motion, no attraction. Gases are fluid, like liquid. Fluid, we said before, fluid, it means gases or liquids. No attractive or no attraction force between molecules of part of gas or particles of gas. So the particles of gas can spread freely and move freely, and we see before it moves in a straight line and elastic collision. Gases has a very low density. Gases have very low densities compared with liquid or solid. No volume equal loss of empty spaces. No volume doesn't mean that we didn't have something, because gas is a matter. It means it has space. So no volume, it means lots of empty spaces, not matter. So from all these postulates of characteristic of gases, we know that figure 3 represent the gas state of matter. Okay, gases can be compressed. No volume, it means loss of empty space. We said it before. Gas undergo diffusion, effusion, and random motion. Diffusion, it means it spread freely, it moves by random motion. Yes, it's called Brownian motion. Moves randomly in all direction. Yes, good. Like this. This figure represents that particles of gases moving randomly and can be compressed, because if we compare between the volume here and the volume in the other figure, it means the spaces in the first figure, it decreases, and all the volume is decreased, but we didn't have a change the number of particles. Number of particles is the same, but the spaces between particles is decreased. So the gases undergo pressed, no volume, lots of empty spaces. We have lots of empty spaces in this graph, and now the spaces it decreased, so it can compressed. Yes, in this figure, the gas, when it closed in container, we have little space between each other, between particles. At this figure, the container was closed. After we release the lid, what happened? The particles start to move outside the container and fill all spaces around the container. So the particles under diffusion, okay, and move randomly in all direction by the same speed and elastic collision. Don't forget this. What's the meaning of temperature? Always uses absolute temperatures Kelvin when working with gases. This is very important note. We must use Kelvin to give me accurately calculation. Okay, so we must use Kelvin. We must use Kelvin, not Celsius. We must use Kelvin, not Celsius. We have different scale of temperature: Kelvin, Celsius, and Fahrenheit. As 0 Kelvin, it equals minus 273, and Fahrenheit equal minus 459. So we will work with Celsius and Kelvin, and we know that to change from Celsius to Kelvin we must add 273 to Celsius to have a Kelvin temperature. Celsius equal 5/9 multiply Fahrenheit degree minus 32, and Kelvin equal Celsius degree plus 273 degree. So if we want to change from Kelvin to Celsius or Celsius to Kelvin, we use this relation. If we want to change between Celsius and Fahrenheit or Fahrenheit to Celsius, we use this relation. But in any equation or any problem, if I give you the temperatures by Fahrenheit, is there a relation between Fahrenheit and Kelvin? You can do this relation and it will be a project for you. Okay, you deduct the relation or send to me the relation between Fahrenheit and Kelvin. It's easy, just substituting about C from this relation and you can measure the Kelvin by Fahrenheit. Pressure equal force over area. Increasing force, increasing pressure. This is directly proportional between pressure and force. But if we increase the area, the pressure will decrease. So if we have 3 shoes, which shoes of this creates the most pressure? If all shoes have the same weight, so which will have more pressure? This contact with earth or land with a low area, and this large area, and this is larger. So the larger one is less one. The smallest one is largest pressure. So the red shoes, it will be more pressure. We use many devices to measure the pressure, like barometer. Barometer measure atmospheric pressure. Atmospheric, it means the column of air between the level of water and the highest point in atmosphere. The weight of this column of air equal 1 atmosphere or 1 atmospheric pressure. Another device is called manometer. Manometer measures contained gas pressure. It compares between the weight of the gas and the weight of the column of air or the pressure inside a container. We compare between the pressure in the container and the weight of the material put in this. And usually we use mercury because mercury has a great density. Yes, good. It's very dense. So we use in manometers to compare or detect the pressure inside container. And we have different scale for pressure, like kilopascal, atmosphere, millimeter mercury, and torr. In any investigation we must use standard condition. Standard condition, it means temperature and certain pressure. Standard temperature and pressure 0 Celsius or yes 273 Kelvin or 1 atmosphere equal 101.325 kilo Pascal. This table represents different measurement for volume and pressure, and we get P multiply V have the same value 7.60 multiply 10 power 3, 7.59 multiply 10 power 3, 7.60 multiply 10 power 3. It's very close to the same value, so we can deduct the relation between pressure and volume. The relation from this graph we see it's inversely proportional. It's inversely proportional. What does it mean? It means look at this column, it's 10, 20, 30, 40. It increases. But if you look to the pressure in other column, 760, 379, 253, 191. So with increasing volume, pressure decrease, and if we opposite the column with increasing pressure, the volume decrease. So the relation is inversely proportional, and P multiply V equal constant. This constant comes from the third column, because if we multiply volume by pressures give the same value. So I can say Poincare law states that the pressure and volume of a gas are inversely related at constant mass and temperature. We must note that at constant mass and temperature. What does it mean, constant mass? It means the container is closed. The same particle inside the container didn't change. Okay? And temperatures, it means the temperatures of the container didn't change at first state and second state, and we will see how we can do this. Look at state 1 and state 2. In state 1, the pressure was 100 kilopascal and the volume equal 1 liter. If we multiply 100 by 1 equal 100, and also if we multiply 200 in state 2, 200 kilopascal by 0.5 liter, it will be equal also 100. So P1 V1, the first state, equal P2 V2. So 1 and 2 represent or refer to first state and second state. How we can solve a problem on Poincare law? A cylinder is filled with air to 60 milliliter at 1 atmosphere. Then the cylinder is sealed and compressed to 20 millimeter. What is the final pressure? We will use the formula P1 V1 equal P2 V2, but we ask about the pressure at the second state or state 2. So we must make pressure as a subject. But which pressure? Pressure, yes, good. Pressure in second state as a subject. How we can do this? As we learn from the math, we must divide by V2 and divide the other side by V2. So V2 will cancel each other in the right side, and we will have P1 V1 over V2 equal P2. So, and I will substituting by P1 equal 1 atmosphere and V2 equal 60 milliliter, V2 equal 20 milliliter, so P2 equal 3 atmosphere. So the volume has decreased from 60 to 20, so I must detect or predict that the atmosphere where the pressure will increase from 1 to 3 atmosphere.